Okay. Well, good morning, everybody. I had a hell of a commute getting here. I'm joking. I live close by. Yeah, my name is John Rodriguez. I'm an Android engineer at Duolingo, and today I'm going to be talking about what's coming up in Paparazzi. So, yeah, let's kick off animations and let's get going. I have not had my coffee. We'll see how that goes. I'm not a morning person. So, let's do a quick recap of what we highlighted last year to kind of set a base state. So one of the major efforts talked about last year was we rewrote this resource loading mechanism. I'm not going to go into the weeds on that because that's what the previous talk was about. But it's important because that was some fundamental groundwork that now will have a second milestone for what I will be talking about. The summary of that is when we originally created Paparazzi, it was during a hack week. We really wanted to kind of have a proof of concept running quickly, and we were doing anything we could to just load resources from whatever, and we looked at the Android Gradle plugin's way of doing it, and we were like, yay, we got it, let's ship. And ultimately we realized looking into plugins output is bad. It's leaking into implementation detail. And it turns out that that limited us for a long time to only run Paparazzi in library modules. We wanted to be able to run it in app modules. And kind of showing my cards ahead of time, we want to make Paparazzi into an SDK. And so we really have to kind of peel away from depending too much on the Android Gradle plugin. This was a fundamental first step. We looked at what the IDE did. Damn it, never can get rid of all the bad magic moves. So what we realized is that what IntelliJ or Android Studio is doing, it has this concept of resource repositories that are very hierarchical. The most lowest levels will look at a resource folder in a module, and then it works your way up into the module level, then the app level, and then you have multiple apps. The reason why Android Studio does this is because it also hooks into the PSI listeners that are part of IntelliJ, because you could be editing resources on the fly, right? It's an editor after all. And so it wants to mutate this hierarchy on the fly and be able to then represent it in either Layout Inspector or the previews, or on when you actually build the app. So when we copied that from the IDE, we stripped out all the mutating part, because when you run Paparazzi in any form, whether in SDK or as a rule, it's assumed that the resources aren't changing from under you. So that's important to know. But by moving to this hierarchy, we lowered heap usage. We were able to support other types of modules. It turns out that the way that we were loading resources before had a lot of bugs, so string plurals, etc., wasn't really working. And theoretically, if you want to not use Gradle, this helped you migrate away from that by being less dependent. I kind of lied. We still have a bug with dynamic features, so we thought we fixed it, and it will be fixed, I promise. But when we advertised this last year, we sold it as fixed. Sorry. Another thing we talked about last year was providing support for different locales and pseudo-localization. We also added widget support, which was nice because if you had a widget before, you had to show a full screen decor view, and that's rather noisy, especially do you really care about the navigation bar? And really exciting, last year we launched accessibility tests, a support for it, both in rendering what the content description and anything else that your talkback would read off from your view hierarchy or composable hierarchy, and also being able to validate a subset of your view hierarchy to let you know if maybe you were doing things that could be improved on. We also supported we also launched minimal support for Google Where, and so all that means is instead of having a rectangular view, you can put in a circular view. I'm sure there's a bit more to it, but that's kind of nice. And yeah, that's the recap of last year. I really wanted to focus on that resource repository stuff because it will come back again later in this talk. So let's flash forward to today. So when we removed, when we launched that old resource loading mechanism, or rather when we launched a new one, we had a time of support of both worlds, because when you rewrite one of the fundamental underpinnings of a library that's growing in popularity, you want to make sure you don't break too many people, or at least give them a release valve so that they can roll back. But it turns out we were mostly right in that, and we were able to soon thereafter delete. And so this environment class is the bootstrap to Paparazzi, and that is what is fed mostly by whatever the Android Gradle plugin tells us. And so whenever we see red lines here, that's great. That means we're depending less on the Android Gradle plugin. And so before we would, the resdir was a pointer to that build intermediates directory that we should never have looked at but did. That goes away. Similar for the assets directory. So something that we recently fixed was the ability to render pending recomposition. So what does that mean? As Paparazzi's progressed, we've added support for Jetpack Compose, and given the way that the runtime works, by doing tree diffing of your hierarchy, it will recompose and print to the canvas whatever state changes have occurred. However, similar to the legacy view ways, sometimes you would have something like a second layout pass or second measure pass in your view. And so the analog to that in Jetpack Compose could result in you missing the first frame of drawing. And so what will often happen is you will use an Android X composable, you're designing your app, and then it doesn't quite look as it should on Android, but then preview will show it as working. And so clearly this is a Paparazzi bug. So we had quite a few of these. And so we just cheat. We look at the first frame, we say, do you have the compose runtime? And if so, let's run another frame pass. Now, one of the kind of key points during the review of this, one of the things that I was very mindful of is, if you take this to the nth degree, you could try to always see if there's pending work and do this for every single frame, and then you become the analog to an espresso idling resource, which can be handy for some use cases, but it is, I think, a design to, if a developer is perhaps writing a custom composable or a view in a way that is skipping multiple frames, we should not render that frame, right? If you're taking 3 frames to render something, we really want to only render the first frame, and maybe the cases of where there's still something recomposing. But if you're taking multiple frames to finally draw it to the screen, that's an error. That's a bug. We don't want to kind of, there's no forcing function to show you that maybe a view was written incorrectly if we supported that. And so at least the design here for now is we want to kind of allow this to happen for things like global positioning and on-text layouts, certain composables where you will need one additional layout pass, but that's it. We'll see how that goes. If there's any reason for additional, we can revisit. One of the other things that we started to do is really invest into the accessibility render extension, which we launched last year. And so we've found some bugs. We've seen some inconsistencies with talkback that say preview is offered, or other options for screenshot testing. And so we're really kind of trying to improve that product, and I'm really happy to see that. Recently, we landed something to support dialogues and sheets. This is particularly interesting because they draw to another window other than the main window, and so they weren't being accounted for. Think of the bottom sheet with the handle that'll pop up from the bottom. I probably should have attached a screenshot here to show you what I mean, but ran out of time. Another nice add recently was the ability to, when you verify your Paparazzi snapshot, if it fails, you get the diff file, but it was somewhere in the file system. You had to kind of crawl there. Taking some inspiration from how the Android screenshot plugin does it, Jeff on the team just decided to figure out how JUnit reporting works and embed it in there. I will say, in reviewing that, I learned a lot about JUnit reporting and how non-modularized it is, not non-configurable. You really have to hack around a lot there. It almost nerd sniped me to kind of want to write a testing framework, but I will not. Cool. Some other things that we've done, not surprisingly, fix a lot of Gradle bugs. As much as I talk about and love Gradle, I tend to find myself writing bad Gradle. I think that everyone in this room can empathize with that. And so one thing that we recently did, it's basically every time we devise a new way to make things better, we wind up breaking something else. It's a nice little whack-a-mole. So in this case, we were setting path sensitivity to none. That was clearly a bad idea because remote caching was failing. If you moved a resource from one folder to another, it wasn't being checked up, considered as moved. That's bad. It shouldn't render anymore. And so seemingly in my analysis, I saw this thing called path sensitivity, where it said, okay, well, we're going to look at the relative paths because I saw somewhere in a doc that absolute paths are bad and relatives are good, so let's just use those. And I probably should have spent more time reading into it. So not surprisingly, another bug came out about variant caching. And here the problem is yeah, it's relative, but it doesn't actually look at the file path. It only looks at the contents of those folders. And Android has a thing called variants. And most of the time, the resources in your debug variant will be the same as the resources in your release variant, but it shouldn't assume that, and it was. And so there were cases where when it was slightly different, or if you updated the version of a third-party dependency, you would be trying to, like for example, if you had on CI, you were building debug and release, whichever one happened to be the most recently cached version in your remote cache, let's say release, future invocations for that path would go to release, but maybe you really want to debug, and then that folder wasn't there, you would get weird crashes. All to say that what we realized is that we probably shouldn't be using paths like configurable file collections with relative path sensitivity. We just decided to still do relative paths, but serialize them as a list of strings using the property mechanism that Gradle provides. And then of course, there was yet another bug similar to the one I just described, but for third-party AARs. The previous one was dealing with local module AARs. And Jeff yet again saved the day, showing me how I suck at Gradle. So here we are. That's the fix for that. But there's more. There was also a configuration cache bug that came up, and yeah, this is no longer a problem because this code was in itself a hack to work around some things until we moved to the modern APIs of the Android Gradle plugin, where you move to things like on variants and you get that callback. Because that API had been around for a while, there were bug fixes that had been only applied to that new API, and because we hadn't yet migrated, we weren't getting those bug fixes. So we hacked around this to fix it, but ultimately fixed it the right way once we migrated to the APIs. And last one, I promise, Gradle themselves reported that there were a couple of issues with how we were caching our test task. If you use build scans or you go into your Gradle build output a lot, and you ever saw something that Paparazzi was doing that screwed up overlapping imp outputs, this is it. It's fixed, and it's shipping in the next release. Basically, verify mode and record mode of Paparazzi were the snapshot output. The snapshot directory is considered the output when you record, but the input when you verify. And that shouldn't be a problem, right? But it confuses Gradle. So we needed to fix that, and we did. Okay. Anyone who saw my Gradle talk yesterday, this will kind of be a small little segment repeat of that, where we wanted to, in order to get Jetpack Compose support and to rush it out in the release, we were copying the jars. Instead of like using normal Gradle dependency resolution, we decided to copy the jar we needed and all its transitive dependencies manually into the project and ship that. And the reason for that, we even did one or the other, is because we are a JVM library. If you were an Android library and you wanted to depend on Compose, you would do it the normal way, put an implementation dependency. But because Paparazzi is a JVM module, when it tries to do that, Gradle gets mad. And so the reason for that is because as a JVM module, you wouldn't know what an Android module is until you inform the build system to kind of figure out what that means. And really what you want is the classes.jar. And so added some diagrams to this to make it a little more helpful than from yesterday. But basically, we had to add some build boilerplate to say, hey, jars are cool. We still want them to be jars, but we're going to classify them as AARs jars. AARs are really cool, but you need a little help, so we're going to kind of unfurl, pull out that classes.jar and pass that along. This is like a true artifact transform. By the way, we do something very similar to get layout lib from its Maven coordinates, unzip it, and then refer to its directory location in the cache, similar to how Android Studio does. So artifact transforms are really cool, and if that's the kind of stuff interests you, I think Nelson and Iñaki from Gradle have given past talks on that stuff. And then to complete the loop, now that we have a way to transform the thing that we want into something that Gradle can recognize, we have to do that final linking and say, hey, now when I ask for, I'm going to create a new configuration called implementation RR's jar, and I want the thing that I just defined from those transforms. Again, more wiring. And all that means is now, in my build.gradle Paparazzi, if I apply this convention plugin in the repo, I can now, as a JVM module, refer to AARs. So, and again, we do that because we want classes.path.jar. Otherwise, things like @composable would not be recognized. And so we do all this simply so we can get composable awareness in an otherwise Java module. All right, moving on. So there are moments where I become particularly proud of Paparazzi. When Jetpack Compose 1.6 was released, I had not taken time to skim the release notes and learn what was new, but I had realized that a bunch of tests at my side of things at work failed. And so I go, oh, clearly this is a bug with Paparazzi. And then digging in, it's like, no, we bumped to Compose 1.6, and so what it did was it changed the default setting of include font padding. I forget from which direction, false to true, true to false, but it changed. And so our tests reflected that, and it caught it, which is very nice. So if I click this, I just do the onion skin thing, and you see that. Normally we see that and we're like, okay, if I didn't intentionally change a line height, then that's a bug. But no, it wasn't. It was because Jetpack, the Compose libraries did, and Paparazzi caught it. So yay, that's what we want. Some other new things is that we've been, as expected, updating the engine of Paparazzi, which we call layout lib. If you've seen me talk about Paparazzi before, you know what that is already. If you haven't, just think of what drives Layout Inspector, what drives Compose previews in the IDE is a core library called layout lib from Google. Until recently, it was not its own artifact with Maven coordinates, and so we had to do some intricate build script magic to kind of relocate that engine, push it to Maven, and then consume it in Paparazzi itself. And so that was the thing we did. And so in January, we updated to Hedgehog. We like updating because it's very nice when we get bug reports if we can say, oops, this is our fault, or oops, it is Android Studio's fault. And what we do is we say, okay, what version of layout lib is Paparazzi on? Let me download that version of the IDE. Oh, they look the same. Oh, they don't look the same. That's like a first level triage. It clears a good amount of bugs. I don't know exactly what percentage. So we updated to Hedgehog. We updated to Iguana 2 months later. And finally in May, we upgraded to Jellyfish. This was a really, Iguana was actually the really important one. And this is the one we're talking about because we've been working on Paparazzi, I don't know, for like 4+ years now. And I think I filed an issue with Google somewhere along that timeline saying, hey, this would be really nice if you deploy this to Maven coordinates. Layout lib is really powerful, we think. And they finally did. And that's nice because one, we get to remove a lot of build script setup. But, and I'll talk about some more positives in a second, but remember environment, we like stripping things away from this. So now that layout lib is its own artifact deployed by Google, they also package all the framework resources that would have been in your platform, like your Android home / whatever it is, platform SDK 29. Previously, Paparazzi would try to be smart and say, what's your Android home? And let's point to the latest that you have set up, and then we'll look there for resources. And that's nice, but then if you were onboarding a new laptop or you were using a sandbox preview and it wasn't like Android -29, but rather it was like whatever, ice cream sandwich preview, things would break, people would get upset, and this is just silly. This all goes away now because you just get all your framework resources from the layout lib runtime, and we get to remove one more thing from environment, yes. Really huge, so like I mentioned or alluded to, layout lib and Android Studio used to be versions and shipped together. Now that they are not shipped together, layout lib seems to follow more the Android platform versioning, which is awesome. It's awesome for two reasons. It's one, the IDE and platform can develop separately as if they don't already. But engineers at Google wanted to be able to use layout lib, whether via Paparazzi, Snapshot, screenshot plugin, or Roborazzi, whatever alternative is out there. But they want to be able to also use versions of Android that we at the public are not privy to yet. They're already one or two releases ahead trying out things. And so this really helps the migration effort. And it also allows people to independently in the community, as the Paparazzi maintainers, if we didn't push this magic relocated version of layout lib to Maven, then no one could even test ahead of us and help us find the bugs. We really had to find the bugs first, and that wasn't a really great position to be in. So no negatives of this. This is awesome. I'm glad it happened. But getting there was not easy. Iguana really broke a lot. And I spent a good 2 weeks trying to figure out why. Some of it was choreographer changes, actually good choreographer changes in Iguana to help support more composed things. They went away from hacking around choreographer to actually using choreographer more. But because we were supporting the same hacks they were, we had to fix our dependencies on that. And so that was great. But I'm going to spend a bit of time talking about the other things that were kind of painful. So Paparazzi, pixel perfection, right? All your images should be the same no matter what platform. And so Iguana kind of really challenged us on that when we saw things like this. Now, this one's a kind of a self-inflicted wound, our delta diffs. So if you take a snapshot and then you verify it later and they don't match, you get a delta diff, which shows your expected, your actual, and the delta of the image reference files. And for whatever reason, we were also affixing our own text labels using good old Java 2D AWT toolkit and writing expected, actual as a kind of clear label to the consumer. And so Iguana changed the way that this text was rasterized. And I go, all right, clearly it must be anti-aliasing. I just need to change some font config settings and we'll work around that. And so I tried, and then I tried. And then I'm like scratching my head, I'm like, what the hell? So I look in the code, and whenever you see your package start with sun instead of Java, you know you're in hell. But on I went. Game over. If you're Mac OS and you turn off anti-aliasing, fuck you, I'm turning it back on. That's what it does. So that's a thing. So, sorry, I don't know if I should curse on droidcon, but I was trying to make an emphatic point. Oh well, it's made. So yeah, the whole way to work around it not having anti-aliasing is futile. It cannot happen. And so what we decided to do in that particular case is we doubled down on our hack. Instead of rendering to the image as text, we first, and so the key thing is we didn't want to render the text to the image on every platform because every platform is different, like how Mac OS, how Linux, and how Windows delegates to their respective rendering toolkits all differ. So what we decided to do instead is render it only on Mac OS from text to a pre-rendered bitmap, check that bitmap in, and then just do a bitmap like merge on the respective platforms. And that's guaranteed to work well because there's no like weird image pixel buffer merging differences on a platform. Anyway, we should probably just remove those labels from the delta diff and have 3 separate images. That's on the queue. But I just wanted to talk about that. That didn't remove all our issues, though. There's still anti-aliasing artifacts in actual text in your text views. The other one was our own fault, but they're still around. And then even if you're not in text, things like gradients also work. And so I was not a graphics expert. I still am not. I talked to my friend Roman Guy, who's really good at this stuff, and I got schooled on like, yeah, don't try to do pixel perfection. It's impossible. And so when I saw red pixels like this, I would bring up a diff editor and just look at the RGB values and I go, the pixel values are always off by 1 or 2. So maybe I'll just relax the diff algorithm to say if your R old and R new are 2 or less, they're equal. And so that is what currently is shipped. And I know that that is not great for now, but it passes for now. A better process would be Roman suggested writing on something that uses SSIM, flip, sift. I have homework from the graphics professor. So if anyone wants to write a flip image diffing algorithm or sift image diffing algorithm, I Googled for 5 minutes, saw that all the work is in MATLAB and Python. So ChatGPT that to Kotlin, ship it. I'm happy to accept PRs. Cool. Moving on. Chris Drury, one of the maintainers of Paparazzi, is awesome. He wrote this animated ping decoder encoder from scratch using OKO platform, multi-platform. He did this quite a while back, but more recently, we landed now the ability to do, finally, video recording in Paparazzi. Paparazzi.gif will give you A-pings. One of the things I should talk about in the feature is that it's going to cover the various ways your animation may change. It'll cover whether the frames are mismatched, whether you have fewer frames than before, more frames than before, if your frame speeds are changed. Look at the PR. There are some nice demos there. Because animated pings don't render in Keynote, I couldn't do a live demo, so I did a quick screenshot. This is a cool example of like where maybe you had a 5-frame animation that, or I don't know, 60-frame animation that's really now 30 frames. And so instead of showing a blank screen that you might think is like a bug on your part, we're like, no, this is actually left blank because there's no frame on this end. And I thought that was really keen of Chris to implement. You may ask, why animated ping? Why not GIF or some of these other things? Just quite frankly, A-ping is a better format. While GIF and A-ping are both lossless, A-pings support compression and chunking. They tend to be smaller in file size than GIFs. What's this? Is it GIF or GIF? I don't know why I never get this right. Who knows? It also supports 24-bit colors and 8-bit transparency, so it tends to be better quality images anyway. Better color palette. If you really want to nerd out, there's a link to what the A-ping spec is. And we do have a demo of this. With this, we were able to now work on Lottie animations in Paparazzi. And so a quick demo there. That's a Paparazzi A-ping recording. Some other work we've done is splitting Paparazzi into an SDK rule. This work began a while back. Brian, thanks for helping out with that. We have a lot more to go there, and I'm going to talk a bit on that. But basically, this right up to now, Paparazzi has been only a test rule because that was the purpose of the project at first. And so everything's literally wrapped in a JUnit rule statement, what have you. But we feel like there's so much more that Paparazzi can do. And so moving this out into, say, something that maybe you could run in a CLI or an app, and then the rule, whether JUnit 4 or conceivably JUnit 5 support will come as a byproduct, becomes a simple wrapper around this SDK, right? You're a snapshotter. Maybe the record verify stuff will stay in the test rule, maybe not, but you can get the idea of like just refactoring code to be reusable is what we're achieving or attempting to do here. I've attempted to take the next step of that is, so we pulled the SDK out of the rule, but it's still in the same module, shipping them as separate modules, and then playing around with the idea of JUnit 5 support would be the natural step of that. And but there's some things that we're still trying to work out before we land it, I should say. I alluded to some pain points that potentially block SDK. I'm going to talk about one of them right now. So I show this image just to kind of point back what I said before. We rewrote the resource repository stuff, right? I recapped on purpose. And I showed you this. Okay, so this tree hierarchy of resources ultimately boils down to some internal three-dimensional map. And so when you ask for a resource, it's going to say the first dimension is the namespace, which is usually res auto. The second dimension is the type of the resource, in this case a string, and then the key is title, and then the resource repository hierarchy will say, okay, what you really want is this resource in this file on the file system. I mean, that was the whole point of this resource repository setup is setting up a database that's keyed by this three-dimensional key. All right. Now, the only problem now is how do you get rstring.title? So when you build an Android app and you have these fun XML files, during the build process is this thing AAPT that'll read your resources and crunch them. But one, we don't use AAPT as much as the app build process is by intention. And furthermore, the little bit that we do, we want to steer completely away from. Like I said, we want to depend less on the Android Gradle plugin. And it turns out that, and so when I say how do we get rstring, I'm talking about this thing. You have, before it was r.java, now it's r.class and r.jar, basically this wrapper of resource indexes that help you get into this three-dimensional map. And the whole point is we rely on class compilation generating these r.jars for us, and then we load them in Paparazzi to index that three-dimensional map. But that's not what IntelliJ does, or Android Studio. It actually generates these ARC for the purposes of layout inspection because you may not have built your app yet. And Compose Preview kind of does this. It says, like, build your app in order to render a Compose Preview. But back in the legacy view day, you didn't really have to do that. You just typed your XML and it would render right away. And in some cases, even the Compose Preview is smart about not asking that. It's only in certain cases where it'll say to recompile. So how does it do that if you're adding resources? It just generates them on the fly. It does some ASM code gen. It will parse, because it has all your resources already in this resource repository hierarchy, it can just traverse that hierarchy on lookup and say, okay, I'm just going to spit out the r.class in the pointer so that you can index it. So that's the thing that we need to figure out how to do with Paparazzi. I have a branch push that basically copied over the Android Studio version of this, and then it's really draw the rest of the OWL at this point in order to land this. But that would be an important part. And so here's the end goal, is like where we can run a CLI, a main method, and be able to invoke the Paparazzi SDK and snapshot something to the file system, none of that not being wrapped in anything that's JUnit test rule or whatever. API differences to change, of course, but this is the general idea. We want to run it on its own. Okay, and let's see. One of the last things I'll talk about is we are really close to landing preview support for Paparazzi. And so what this means is in your Compose previews, right, currently, either if you use Emerge Tools or the Android Screenshot plugin now, the ability to slap an annotation or use the currently existing annotations and generate a screenshot. And what the design currently is you add an @Paparazzi annotation alongside your Compose previews, and for free you will get a Paparazzi snapshot. At the moment, the design will be to generate a test source and then run that test source. We're hoping that in the evolution of this, we will then move to the SDK and bypass the need to code gen test sources only to then run those test sources. We can kind of skip that, but we'll see how that goes. And if you want to follow the milestones and issue trackers or file bug reports, give feedback, that's the link to the repo. And thank you.